minus 128.6 degrees Fahrenheit. That number was recorded on the surface of our planet, not in a lab, not in a controlled environment. Outside, in the open air. It's colder than the coldest temperature ever measured on Mars. At that temperature, your breath doesn't just fog, it freezes before it leaves your mouth. Exposed skin lasts less than a minute. Fuel lines crack. Steel becomes brittle. The cold stops being something you feel and starts being something that kills you with almost no warning. And people have survived here for over a year at a time. This continent holds 90% of all the ice on Earth and 70% of its fresh water, locked inside a sheet of ice so thick that if you stood on top of it, you'd be at the altitude of a cruising aircraft. If that ice melted, all of it, every coastal city on the planet would be underwater. London, New York, Shanghai, Miami, gone. But here's what most people don't realize about this place. Technically, it's a desert, not a frozen wasteland, a desert. It receives less precipitation than the Sahara, less than the Atacama. The snow you see here didn't fall recently. Most of it has been accumulating for hundreds of thousands of years. It's also the windiest place on Earth. Winds here regularly hit over 100 miles per hour. During the strongest recorded storms, they've exceeded 200. There's a name for these winds: katabatic winds. Cold air rushing down from the polar plateau with nothing to slow it down, nothing to break it, just open ice for 1,000 miles in every direction. And 6 months out of every year, the sun simply doesn't rise. This is Antarctica, the coldest, driest, windiest, and most isolated continent on the planet. A place so extreme that no human being even knew it existed until 200 years ago. But underneath all that ice and silence, this continent has a story that almost no one knows. And it starts with something that will completely change the way you think about this place. "60 million years ago, Antarctica had forests. Not scrubby, frost-resistant shrubs clinging to rock. Real forests, tall trees, ferns covering the ground. A landscape that looked closer to the Pacific Northwest than anything you'd associate with the bottom of the world. We know this because the trees are still there, frozen inside the rock, preserved by the same cold that makes this continent so hostile to life today, are the fossils of an ancient forest. Leaves, bark, root systems. Scientists have pulled them out of the ice and held them in their hands. Remnants of a world so different from the one we know that it barely seems possible they came from the same place. And it gets stranger. Dinosaurs walked here. Not just small ones, large predators, the kind that dominated the planet during the Cretaceous period. Their bones have been found in the Transantarctic Mountains, buried under ice that formed millions of years after they died. So how does a continent with forests and dinosaurs become the frozen wasteland it is today? The answer is plate tectonics, the slow, relentless movement of the Earth's crust that has been reshaping this planet for billions of years. Antarctica wasn't always at the bottom of the world. It was once part of a massive supercontinent called Gondwana, connected to what is now South America, Africa, and Australia. It sat at lower latitudes, close enough to the equator to support lush vegetation and diverse animal life. Then the plates shifted. Over tens of millions of years, Antarctica drifted south. Slowly, imperceptibly, a few centimeters per year, until it settled over the South Pole. As it moved, the ocean currents around it changed. A powerful circular current formed, the Antarctic Circumpolar Current, isolating the continent from the warmer waters of the north and trapping cold air above it. The forests died, the animals disappeared, the ice came, and it didn't stop coming for 34 million years. What this means is that the Antarctica we think of as permanent, that blank white shape at the bottom of every map, is actually a relatively recent accident of geography. A continent that spent most of its existence as something else entirely, locked into its current form by a slow drift it had no control over. The ice we see today isn't ancient in the way we imagine. It's the result of a process that's still happening, still shifting, still changing. And understanding that changes everything about how we read what's happening to this place right now.
Most places on Earth have a natural thermostat. The ocean absorbs heat during the day and releases it at night. Clouds trap warmth close to the surface. Forests, soil, humidity, all of it acts as a buffer, keeping temperatures within a range that most life can tolerate. Antarctica has none of that. Start with the ice itself. White surfaces reflect sunlight instead of absorbing it, a phenomenon called the albedo effect. In most places, the ground soaks up the sun's energy and converts it to heat. Here, up to 90% of that energy bounces straight back into space. The continent actively refuses to warm up. Then there's the altitude. The Antarctic ice sheet isn't flat, it's a dome. The center of the continent sits at over 9,000 feet above sea level, higher than most mountain ranges in Europe. The higher you go, the colder the air. Antarctica combines polar latitude with high altitude, which is why temperatures here make the Arctic look mild by comparison. And then there are the winds. Cold air is denser than warm air. On the high polar plateau, cold air builds up and has nowhere to go but down, rushing toward the coast under the pull of gravity, gaining speed as it goes. By the time these katabatic winds reach the coastline, they can hit 150 miles per hour without a storm, without a weather system, without any of the triggers we associate with dangerous wind back home. Just physics. Just cold air falling downhill for 1,000 miles. These winds don't just make Antarctica colder, they reshape it. They scour the ice, carve valleys into rock, and create some of the most surreal landscapes on the planet. Places where the ground looks polished, where the snow moves horizontally instead of falling, where visibility can drop to 0 in seconds on a perfectly clear day. But the most disorienting thing about Antarctica isn't the cold or the wind, it's the light. Because of the tilt of the Earth's axis, the poles experience something no other place on the planet does. Months of continuous daylight followed by months of complete darkness. At the South Pole itself, the sun rises once a year in September and sets once a year in March. For 6 months, it circles the sky without ever dipping below the horizon. For the other 6, it simply isn't there. That darkness does something to the human mind that researchers are still trying to fully understand. People stationed here during winter describe a psychological phenomenon called the long eye, a kind of mental flatness that sets in after weeks without sunlight, where time loses its shape and the boundary between sleep and waking starts to blur. And yet the darkness has a reward. Without light pollution, without atmosphere thick enough to scatter the stars, the night sky above Antarctica is unlike anything visible from anywhere else on Earth. Astronauts returning from the International Space Station have said that the closest thing they've seen to space, the real overwhelming scale of it, was standing outside a research station in Antarctica during the polar winter, looking up. This is a continent engineered by the planet itself for extremity. Every system that normally softens the edge of a place, ocean currents, humidity, vegetation, light, has been stripped away here, leaving something raw and almost mathematical in its hostility, which makes what lives here even harder to explain. The krill is about 2 inches long. It looks like a translucent shrimp, weighs almost nothing, and individually would be completely unremarkable. But there are estimated to be 500 trillion of them in the waters around Antarctica, a total mass greater than that of every human being on the planet combined. And almost everything alive in this part of the world depends on them. Antarctic krill survive by eating microscopic algae that grows on the underside of sea ice, a food source that exists nowhere else on Earth in the same way. They can slow their metabolism to almost nothing during winter, shrinking their own bodies to conserve energy, and then rebuild themselves when conditions improve. They've been doing this for millions of years, in water that hovers just above freezing, in an ocean that spends half the year locked under ice. Everything else here, the penguins, the seals, the whales, the seabirds, exists because the krill figured it out first. Take the emperor penguin, the largest penguin species on Earth and the only animal on the planet that breeds during the Antarctic winter, not in spite of the cold, but in sync with it. When every other creature is moving north, away from the darkness, emperor penguins march south, deep into the continent, away from the ocean and the food supply, in temperatures that can hit -40, in winds that can exceed 100 miles per hour. The males stand in total darkness, balancing a single egg on their feet, eating nothing for 2 months. They survive by forming huddles, thousands of birds pressing together, rotating slowly from the outside of the group to the center, so that no individual stays exposed to the wind for too long. The temperature inside one of these huddles can be nearly 100 degrees warmer than the air surrounding it. It's one of the most sophisticated collective survival behaviors ever documented in the animal kingdom. And it happens in the dark, in the cold, in one of the most remote places on Earth, completely out of sight from the rest of the world. Below the surface, the adaptation gets even stranger. Antarctic icefish have no hemoglobin, the protein that makes blood red and carries oxygen through the body in virtually every other vertebrate on the planet. Their blood is completely colorless. To compensate, their hearts are enormous relative to their body size, pumping a much larger volume of blood to deliver enough oxygen to survive. They've essentially reinvented cardiovascular biology from scratch to deal with water so cold it would kill most fish within minutes. And then there are the tardigrades. Less than a millimeter long, invisible to the naked eye, tardigrades might be the most resilient animals ever discovered. They've been found in Antarctica, surviving conditions that would destroy almost any other organism. Temperatures near absolute zero, radiation levels that would be lethal to humans, complete dehydration for decades at a time. When conditions become too extreme, they essentially turn themselves off, entering a state called cryptobiosis, where all biological processes stop completely, and waiting, sometimes for years. Scientists have revived tardigrades that had been frozen for over 30 years and watched them start moving again within hours. What Antarctica teaches us about life isn't that it's fragile. It's that life is far more stubborn than we give it credit for. That given enough time and enough pressure, biology finds a way to work with conditions that seem designed to prevent it entirely. Every species here has been running that experiment for millions of years. The krill in the freezing water, the penguin in the dark, the icefish with its colorless blood, the tardigrade waiting out the impossible. None of them are surviving Antarctica despite what it is. They're surviving because of it. But as remarkable as the animals here are, the most extraordinary story of survival this continent holds isn't about any of them. It's about us. In 1911, two men set out to reach the South Pole at the same time. Roald Amundsen was Norwegian, pragmatic, precise, using dog sledges and techniques learned from the Inuit. Robert Falcon Scott was British, methodical, traditional, convinced that determination alone could conquer the ice. Amundsen reached the pole on December 14th. He planted his flag, left a note for Scott, and turned around. Every single one of his men made it home. Scott arrived 34 days later. The tent was still there. The flag was still there. The note was still there. Scott and his 4 companions died on the return journey, pinned down by a blizzard less than 11 miles from a supply depot that could have saved them. His diary was recovered with his body. His last entry ended with a sentence that has never stopped being quoted. "I do not regret this journey." But the story that defines this era more than any other isn't Scott's tragedy or Amundsen's precision. It's what happened to Ernest Shackleton 2 years later. His ship, the Endurance, became trapped and crushed by pack ice before the expedition even reached the continent. For nearly 2 years, Shackleton kept 27 men alive on the open ice and ocean, eventually crossing 800 miles of the most dangerous sea on Earth in a 22-foot boat to organize a rescue. Every single one of his men survived. The same continent that killed Scott's team became the backdrop for one of the greatest survival stories in human history. 2 expeditions, same place, completely different outcomes. Antarctica doesn't care about your intentions. It only responds to what you actually do when everything falls apart. A century later, people are still coming here. Not with wooden ships and dog sledges, with satellites, helicopters, and laboratories drilled deep into the ice. Because buried inside the Antarctic ice sheet is something no other place on Earth can offer. A climate record going back nearly 1 million years. As snow accumulates over hundreds of thousands of years, it traps tiny air bubbles, snapshots of the atmosphere exactly as it existed at the moment each layer formed. Scientists drill down and pull out cores that read like a timeline of everything that ever happened to this planet's climate. What those cores show is unambiguous. Every time carbon dioxide levels rose in Earth's past, temperatures followed. Every time they dropped, the planet cooled. The pattern repeats across 1 million years of data with a consistency that leaves very little room for interpretation. And in 1959, in the middle of the Cold War, with the United States and Soviet Union pointing nuclear weapons at each other, 12 nations signed the Antarctic Treaty. No military activity, no territorial claims, no resource extraction. The continent reserved exclusively for peaceful scientific research, open to all nations equally. It has held for over 60 years. 54 countries have signed it. Russian and American scientists have shared data on this ice through every geopolitical crisis of the last 6 decades. There is no other place on the planet where that is true.
The Thwaites Glacier is roughly the size of Florida. Scientists have given it a nickname that reflects exactly how seriously they take what's happening to it. They call it the Doomsday Glacier. Not because of exaggeration, because of what the math shows. Thwaites holds enough ice to raise global sea levels by 2 feet on its own. But the real concern is what it's holding back. A much larger section of the West Antarctic ice sheet that, if destabilized, could push sea levels up by an additional 8 to 10 feet. In 2023, researchers found warm ocean water that shouldn't be there, eating at the glacier from underneath. Not from above, where satellites can monitor it, from below, where it's almost impossible to stop. The ice cores that gave us nearly 1 million years of climate history show something that puts all of this in context. The level of carbon dioxide in the atmosphere today
is higher than at any point in that entire record. Not the highest in recent decades, the highest in nearly 1 million years of Earth's documented climate history. And the continent that accumulated that ice over 1 million years is now losing it faster than at any point in recorded human observation. But Antarctica also shows us something else, something that gets far less attention. The ozone hole that opened above this continent in the 1980s was one of the first global environmental crises humanity identified and named. An international agreement phased out the chemicals causing it, and it worked. The ozone layer is healing. It is on track to fully recover within decades. We identified a problem, we agreed on a solution, and it worked. Antarctica holds both of those truths at the same time. The evidence of how much damage a species can do without even trying. And the proof of what that same species is capable of when it decides something is worth protecting. The ice beneath this continent formed before our civilization existed. The wind doesn't register our presence. The silence here, on the rare moments it stops, is so complete that people describe hearing their own heartbeat for the first time. We are the first generation in human history to watch this place change in real time. What we do with that, what layer we add to the record, is still being written. And that, more than the cold or the wind or the scale of this place, is the thing worth sitting with. Antarctica is just one of them. All over this planet, there are places that push against everything we assume we know. Places that have been here longer than our languages, longer than our religions, longer than any story we tell about ourselves. We drop a new documentary every week. If you want to be there when we find the next one, subscribe. And before you go, we want to hear from you. If you could spend 1 week anywhere in Antarctica, a research station, the open ice, the coast with the penguins, where would you go and what would you want to see? Drop it in the comments. We read every single one. Until next time.